Hello, this is Hisham from Team 1, Sub-Team A, and I'll be briefly going over how Hossam and I worked to implement this task. We were supposed to develop the GPIO driver for the TVC controller and use it to control the RGB LED on the board using a push button. We were supposed to use the push button to generate this sequence on the RGB LED. So at the first press of the button, the red LED would turn on, and it would stay on either for 1 second or until the button is pressed again. So if we press the button again before this second is over, then the red LED would turn off anyways, and the green LED would turn on and would also stay on either for 1 second or until the button is pressed again. At the third press of the button, the blue LED would turn on, and same as the previous ones, it would stay on for 1 second only or until the button is pressed again. And at the fourth press of the button, all the LEDs would turn on for 1 second only, and at the fifth press all the LEDs would turn off, and if we press the button again we would be repeating the sequence back from the top. So to implement this sequence, we implemented drivers for the GPIO, SysTick timer, LED, and button, all of which we had already implemented in one way or another in the previous task. So we went on to optimize, add features and functionalities to our drivers. And for me, those were the GPIO and button driver. So I just worked to fix some bugs and add some features, mostly in the concerning the interrupts. And then I went on to debug the application along with Hossam, who will now go over his work and test the application. Thank you.
Thanks, Alaa. This is Hossam Elwahsh. As Alaa was saying, we were working on the LED control version 2, which is just an improvement over the version 1 project, which just involves an extra 1 second duration for whichever LED is currently on. For my part, I made some improvements for the system-tick module to support interrupts or asynchronous delays. For this module, it's currently used by the button driver for the debounce, and also by the application module or driver for the 1 second delay or duration for each of the LEDs. These are the added APIs to the system tick and a synchronous function for an MS delay. The system tick handler and a set callback API to notify back the upper layers when the system tick is finished counting synchronously. The MS delay just an extra process to disable interrupts. Both of these APIs have a note that they won't work together, meaning that if you call the MS delay, it will cancel any synchronous delays immediately, which is really helpful in our case. The application doesn't need the previous LED to be on if the button was pressed, which will turn on the debounce for 200 milliseconds, and also will cancel any asynchronous 1 second delays. Okay, and also some improvements were made to the application layer. Alaa helped with the flowcharts, and also the debugging for the application layer. We added an extra function called switch state to turn off or turn on the requested LED, and also initiate the asynchronous delay, and also a system tick callback that will switch the application state to turn off, which will turn off the current turned on LED, This one is cooled after the 1 second has elapsed. And the regular App Store super loop, only having 3 states: idle, doing nothing, switching, which will call the switch state and switch the appropriate the needed LED to be turned on, and the last state turning off, which is called after the 1 second delay has elapsed. Okay, so summary, we have two levels of states in our application: the main states, which are idle, switching, turned off, and the substates, which are all either off, red on, blue on, green on, all on. Okay. We also added a linking configuration to the system-tick driver. It only holds the clock source and the pointer to the callback function, which you can actually set using the set callback API. Anyways, okay. Moving on to the hardware testing. For the test protocols, there are the same two cases in version 1 and an additional case. This one wasn't a requirement, but we added it. If you press the button during the 1 second delay, it will cancel whatever is currently on. It will switch to the next state. The current LED turns off immediately, and the next LED turns on for 1 second, which is the next state. We don't know if this is required or not, but we just implemented it for ease of use. Okay. Okay, moving to Kyle. Options for target, debug using the ICDI. Our TVC is connected. Okay, just in case, we'll rebuild, load. You can see our TVC connected, powered on. Click on reset. Clicking this button will turn on the red LED for 1 second. Click it again, it will turn the green one. Again, it will turn the blue one, and then the white. And then turn everything off. And I will double click during the red light. It should cancel the LED, the red light, and move to the green. So red, green, blue, white, red, green. It will turn off after 1 second. Okay, and that would be it. Thanks for watching.